A main way that respiratory germs move between people is through the air. A sick person exhales particles that carry germs, and these particles are inhaled by someone else. It would seem natural then that the risk of disease transmission is connected to indoor air quality in some way. But how? Let's explore this. First, let's remember the 3 R's of indoor air quality: remove, reduce, and remediate. What does it mean to remove a source when it comes to respiratory diseases? Well, if sick people are the source, removal means that they're not in the room or building. In the case of public buildings like schools or places people work, this means that people are able to stay home while sick. Unfortunately, not everyone is able to stay home when they're sick. And even when people can stay home, we need to consider that they might be, infecting others in their home. And let's also remember it's possible to be asymptomatic. Someone does not have to look sick to still be infectious. All of this means that removal as a strategy is more complicated for respiratory diseases than for many other indoor air quality issues. How about reduce? Reduction can mean things like wearing face coverings, also known as masks. Masks serve as a filter to remove particles from the air right at the source, our mouth, our nose. The effectiveness of masks at removing particles and thereby reducing disease transmission depends mostly on how well they fit, but also on what they're made of. In this case, fit means how well the masks make a seal around someone's mouth and their nose. Usually masks with head straps like N95s fit more tightly than masks with ear loops like KN95s or surgical masks or even cloth masks. When we think about the combination of fit and how well the mask can filter particles, this means that N95s are usually going to be the best choice, followed by all of the other common masks, including KN95s, KF94s, surgical masks, and cloth masks. However, people must wear masks for them to work. If someone finds a mask especially uncomfortable, they're not going to wear it. And different masks will fit better or worse on different people. So you'll want to find the mask that will work best for you. Also, because there can be infectious people who do not seem sick, masks are most effective as a source reduction strategy when everyone wears one. Masks play an important second role too. Besides reducing the amount of germ-carrying particles exhaled into the room, they can also reduce the amount of particles that people inhale. When we inhale and the air passes through a mask, some of the particles are filtered and removed from the air before they can get inside our mouth and our nose. Another way that we can reduce the potential for transmission is to reduce the number of people in a room. This is because the chances that one or more persons is sick goes up as more people are packed into a room. Additionally, an excellent control and prevention strategy is population-wide vaccination. Vaccines exist for many viruses that cause respiratory infections, and these can help to both prevent infection in the first place and to decrease the symptoms that we experience if we do get sick by giving a boost to our immune systems in advance. Staying up to date with the latest vaccines helps reduce the amount of people who get sick and slows the spread of diseases. So what about the third R, remediation? We're going to get into this a lot more in the third set of modules, but we can generally say that remediation can include ventilation, filtration, or even deactivation or disinfection of the air. The goal of all of these remediation strategies is to reduce the amount of germ-carrying particles in the air, whether by flushing out the dirty air with clean or by filtering particles out of the air or another strategy. Because more germs in the air means more risk of people getting sick, we use remediation to lower the risk of people getting sick by lowering the amount of germs in the air.